IEEE President and CEO, Jose Mora.
Thank you very much. Good morning, everyone. As you just heard, I'm Jose Mora. I'm a professor at Carnegie Mellon University, and this year I have the pleasure of serving as IEEE President and CEO. I'd like to start and take a moment to recognize the efforts of many people whose dedication, hard work, and expertise helped to make this event possible. If you had walked to the back a couple of hours ago, you'd see an empty room. Now it's full of stuff. Amazing how they can do that. I'd like to provide a special thank you to this year's silver partner, Viasat. We are thrilled to host such a diverse collection of speakers and award recipients from around the world and across the broad spectrum of engineering disciplines to provide the opportunity to experience the multitude of leading-edge viewpoints on technology and innovation. As the world's largest technical professional society, IEEE, with its 422,000 members and a footprint of 160 countries, IEEE is at its best when we bring together the totality of our offerings with the rich diversity of our global community of professionals from academia, government, industry, to address the many technology challenges and opportunities that lie ahead. We are here today in a very special day for IEEE. Simultaneously, we are at the IEEE Vision Innovation Challenges Summit, and later on, at the end of the day, we will have the awards gala. Both meetings are to recognize that we live in very interesting times of revolutionary technology changes. And this meeting today, it's an opportunity for young professionals of all ages to meet the great technologies that are responsible for all the revolutionary challenges that we experience. And later tonight at the awards gala, we will have the opportunity to recognize the leaders that whose main contributions have so much contributed to the interesting times we are living. Thank you.
I first became a computer scientist in the mid-'80s, when in computer science, women were close to 40% of computer science grads. I've always had a passion for creating technology, but all too often, they left the field. And after that, also, the numbers of computer science grads dropped. Right now, it's about 20%. The Grace Hopper celebration celebrates the achievements of women. We founded it in 1994 with about 500 women to celebrate their achievements. In 2018, we had 22,000 people, 95% of which were women. It's a celebration of their achievements. It's a chance to come together, and well over 300 companies who are dying to hire more computer scientists. It's a very exciting and rewarding conference. You know, the first time that I remember being drawn to technology was in the summer of 1969. Now, this is Southern California with those sultry nights. I was at my aunt's. We had those old-fashioned TVs, you know, they didn't even have a remote. They had dials. It was on a push cart. We were out on the outside, and we were landing on the moon. It was, I was completely absorbed with it, this idea of the technology that allowed that to happen. Now, from where I sit today, I think back on that 13-year-old girl And you can see how it was drawing me in. How many of you were around in 1969? A few. But I didn't have any engineers or scientists or technologists around me, so I'm not sure that I even recognized that yearning to contribute to technology. And I think of that today because so many young people in middle school, that same age, still do not have access to role models of all of you, to the remarkable people and the impact that technology can have on their life.
Focused on smart city innovation to help cities and companies around the world understand the acceleration of technology and how it can be done faster, better, with bolder, bigger ideas. And that's really what this is about at IEEE. They've decided to have a smart cities track at the convention, and it's really focused on smart networks and what companies, what engineering, what innovation is going on in the world that really helps transform cities. 10 billion, the world population in 2050. If you don't know, today it's about 7. Look at the second number. 8.5 billion people will live in cities in the year 2050. And I will tell you something, they're not ready for it. Population growth, climate change, lack of good infrastructure, lack of inclusion. These are challenges which every city in the world will be facing in the future.
Most of us spend approximately 80 or 90% of our awake time inside buildings. So having buildings that are comfortable with nice air quality, nice sun lighting conditions, makes our life more enjoyable, more fun, easier. Also, it makes us more productive. And I think American companies have caught up with that, and you see a lot of efforts in that direction. So what is the definition of a smart building? We kind of have an idea what a smart city is. Well, a smart building is one where it has all the amenities we like, a nice air quality, nice lighting, it makes our life easier. It's also safe and secure. And in case of emergencies, it can respond quickly. If there's an earthquake in San Francisco, I would really like to make sure I survive being in the building I am at UC Berkeley. And more importantly, smart buildings are those that can do all of what I just said, but in an energy efficient, sustainable way.
2020 is quite famous because, again, that's where 5G is coming into the scene. But as you could see here, it will start impacting social value. And then you see more of an open type of innovation between customers and partners. And that will lead to creating greater social value in terms of safer cities, quality of life, industry, ecosystems. So this is why we're really at the beginning to witness unprecedented growth for all of us to participate in. The challenge is which area you want to chip in, how you are going to help. The comment I wanted to leave you with, none of these things can be done by an individual company or individual effort. This is all done collectively, and that's the amazing part of IoT and 5G. It's really bringing about the whole community to move forward and bringing in a different direction, a greater value.
Well, most of you have probably heard of a public health crisis affecting your community or the community of someone you know. So this could be opioids, which is currently one of the top health crises in the US, or outbreaks of infectious disease, contaminants in water, which can lead to some pretty serious health consequences, or more recently, measles outbreaks from around the country. But what's notable about all of these is that we only really hear about it when the crises turn into catastrophes, and then all we can do is damage control. But if we could somehow gather information about the health of the city before these things happen, then we might be able to better react to them or even prevent them. So we're here, this panel is about smart cities. What if we were able to gather information from around the city and turn this into a human health database that's powered by everyone in the city.
And what I want to talk to you today about is ethics in AI and why it's important that we think about it and why I care about it. So one of the things right now is that robotics and AI, it is at the cusp of impacting everything that we know about, everything that we do, our daily existence, our daily life. And the fact is that we need to think carefully about how we deploy these systems. I'm a roboticist. I make and design and create robots and artificial intelligence by understanding people. And one of the things that we as roboticists don't want to happen is our robotic creations impact the world in a negative way. And so one of the things that we know is that our systems have some bias, and why is that? Is because we learn from data that's available in our society, in our world, and that data has historical biases because we as people, we have our own implicit and sometimes overt biases. But we can make our systems better than us. We can make our systems and our AI agents actually teach us a little bit about our own humanity. I truly believe that. And as robots and AI systems are used in education and in healthcare and in transportation, it is really our duty as engineers and computer scientists to ensure that it's all just the good and not the bad.
What sort of tasks do we want these robots for? So there are some sort of tasks where it might be interaction is really important. There are other sort of tasks where it might be, well, perhaps you want some sort of like robotic assistant to a human being, but where there's a very kind of domain-specific task for which this social nature is less important.
So if these systems are going to be everywhere, and at least that's my humble prediction, which areas will be the first ones to be affected, and how do you think people will react to that change, to this robot revolution? Is that something people are going to be excited about, or are they going to be afraid of the Terminator, or what's your take on that?
Yeah, so actually, because you mentioned this thing about jobs, would you want to take that first?
Yeah, so my sense is that, jobs, and in particular, jobs that don't require much mechanical skill are an area where robotics has made a lot of headway, and indeed where we might think, well, actually that's a real kind of net positive, because there are a lot of dangerous jobs, dangerous work that perhaps we think, well, this is not work a human being ought to be doing, and so it's a kind of great political advance if instead we can pass it over to a robot.
But is that really then social robotics, or is that just industrial automation that is going to go on? So do you have any opinion on how in social contexts people will react if we automate more of their daily life and not just of their work life? Yeah, I think depends a lot on the kind of institutions they're living in and resources they have. So I think in a lot of contexts, for example, a nursing home, you might think, well, we have a big problem that nursing homes are really under-resourced. And so a thing that we might do is make a kind of what we might think of as an ethical advance by introducing more care robots to aid in these sort of things. But we might step back and say, well, maybe in a more perfect world, is this the sort of intervention we should be making, or another one? So it might be that, in fact, there's a sort of positive reaction, but for bad reasons. Namely, people aren't getting the kind of resources and support that they should be getting.
Yeah, so I think one of the things, kind of piggybacking off of that, I think where robotics, especially social robotics, can really have an impact is in healthcare. We always tend to say, well, robots, they come in, like in terms of a nursing home, we're removing the human element, but frankly, the human's not there, right? Like kids aren't necessarily going to see their grandma or grandpa if they're in the homes. So I think that robots can function in that. And one of the things about social robotics is that it doesn't matter what the gender of the person is, the culture, or whether something comes out of their mouth that shouldn't. The robot will interact with them based on who they are.
Kevin?
Yeah, I certainly think the first place that we've seen robotics really come mainstream is in the industrial robotics. So it's taking out the tasks, it's taking out the processes, it's taking out the the jobs that are probably too risky, too dangerous for a human to do. And so we've seen a great push there. Then I would agree. I think the next probably big area, just because of the need and the demand from an industry perspective, is going to be in healthcare, probably in elderly healthcare. And you could say we'd love to see other people do that and kind of step up to the plate. Right now, there is a supply-demand imbalance in healthcare, and so a robot could potentially take that place. And whether it's a robot or a real person, something there for an elderly individual to keep them company, to make sure that they're taking their prescriptions on a regular basis, to even just say good morning to them is better than no one. And that's really the situation that we have right now. After healthcare, I think you might start to get into some more customer service-oriented industries. So you think of travel, transportation, and logistics, places where you have a lot of interactions with customer service. If that can potentially be automated and a social robot could come into that construct, that industry could actually find some real value there as well.
What I wanted to talk about today is my presentation that I presented here at the Innovation Summit about X-59, the supersonic technology demonstrator that Lockheed is building for NASA. It's a very important project for us and for NASA because it is something that is going to change for the general public, allowing people to travel much faster than they ever were in the past, essentially going from point A to point B. What we're trying to do is to create a shape of an airplane that reduces that noise to what NASA likes to coin as a supersonic heartbeat, which is about the equivalent of a car door slamming. So if that new shape of an airplane was to fly over us right now, you wouldn't even notice it, just with the amount of noise that's in the room here. So I'm going to talk to you about the things that we're doing to actually develop this technology and where we're at with this project.
We brought robot butterflies and a robot dragonfly, and we try to analyze how nature does things and then copy those in robotics, so that in the end we hope to learn from nature how the robots of the future are going to look like. And you're going to see a short demo in a second, and we're also going to fly around the whole evening outside, so if you have questions, please come around. So especially the butterflies, they are an application of AI actually, because you don't have to control them anymore. They can fly by themselves, but we brought our pilot because in closed rooms it's always better if somebody flies it. So yeah, please go ahead. Oh my God. So this is what you can copy from nature, and we also have a robot kangaroo, we have a robot, a flying dog, we have well all different kinds of robots, and yeah, obviously there is no commercial interest in that right now. Think of robots that are having a swarm of those, like hundreds, 200s of those, and just going into a disaster area and mapping the environment and all that. So that could be a future application. And yeah, as I said before, we also have the robotic dragonfly. Oh yeah, and actually it doesn't harm anyone if you get it on your head. The robotic dragonfly has 13 degrees of freedom. It can hover in midair. It can control all the wings separately. It could land actually on walls. We have been looking into that as well. And yeah, some of you who might have seen some coverage of Mars, so the robotics conference hosted by Jeff Bezos, this has also been at Mars this year, and so we thought it might be nice for you to bring it here. Sorry. The interesting part is, and why you need AI for that, is actually in order to maneuver with those four wings that are independently operated, and you can operate the altitude, the amplitude, you can change the frequency, and you can also change the angle of the wings, and this is actually no longer being possible to be handled by the pilot. By the way, give a hand to Marcus.
To simplify, Temi is basically a tablet on wheels or a virtual assistant with the screen with full autonomous navigation. We currently have the most advanced indoor navigation system in the world, incorporating 16 different sensors, the most famous one being the LiDAR, the 2D mapping, and with other 15 friends, we have full obstacle avoidance. The advantage for such a device with indoor navigation, for the consumer level, the most exciting application would be moving video calls. So I can hop into my robot in my office in Manhattan right now and tap just buttons on the screen, conference room, graphic designer, repairs area. The robot will drive there autonomously while avoiding obstacles, my puppy's toys, and other employees. So I can be at 2 places at once.
The Guardian S is primarily a remote visual inspection tool and remote sensor platform. It can carry a 10-pound payload on a horizontal surface and a 5-pound payload on a vertical climb. So it does have magnetic tracks, and it can climb ferrous magnetic surfaces. So Sarcos's vision is to save lives and to reduce injury by deploying advanced human-controlled robots to promote visual inspection and to keep people out of harm's way. So where people should not go or it's too dangerous to be, we want to deploy robots to help them do their jobs better and more safely. So it is, as I mentioned, a remote visual inspection tool. So on the front of the robot, we have 360-degree cameras, top-facing camera side, back and otherwise. We have an IR camera. On the back, we have a wireless radio system. So this is a very unique inspection robot in the fact that it is wirelessly enabled, multiple frequencies, can also communicate over enterprise Wi-Fi, and it does have an LTE module. So we have worked with some of the commercial cellular providers to wirelessly enable it over 5G. As a remote sensor platform, we've put any number of devices and meters on the robot. We've put 5 gas meters for, again, confined space inspection to go ahead of the inspector to make sure that the environment is safe for them to enter. We've put 3D LiDAR and scanners on the robot. And we have enabled some radiological and nuclear detection devices.